But yeah, so yeah, they're right.
And if you just put sure it's
Hi there. You're in V6OPS. If you think you're somewhere else, you're in the wrong place. We're in a room the size of Mammoth Cave. I wonder if we could consolidate into a smaller part of it. And specifically, I have 2 blue sheets, and I don't know how they're getting over to that section. So that needs to happen. Is that on now? Okay. So, okay, I'll repeat myself. Hi, if you're in V6OPS, if you think you're somewhere else, you're in the wrong place. We're in a room the size of Mammoth Cave. Could I get you guys to consolidate into, the North American continent? And specifically, we have 2 blue sheets. I have no idea how they're getting over to that area. So, okay, now, and of course, I've got 1 chair and 3 laptops. But okay, here's what's going on. Yesterday, we got more done than the agenda actually had planned, and which is a good thing, because a number of us have gone home overnight or are on the way out the door this morning. What we have left this morning are essentially 2 AOB drafts. Do I need to swallow it? Okay, I'm sorry. Are those mics working? I didn't check them. But okay. What we have this morning are essentially 2 AOB drafts. People that came to Ron and I and said, if you have any extra time, I'd like to get operational input on my favorite draft. Well, we have some extra time this morning. So as a matter of fact, we have the room until 11:30. If we want to just talk, we can do that. On the other hand, there's no point in prolonging things. So, we'll be very flexible this morning. But yeah, so Mr. Patterson, are you here? Okay. With any luck, this, yes. Okay. And you need to stand inside that little box. Oh, Barbara, are you taking notes this morning? I would love if you could do notes this morning. Thank you.
Okay, hello. Sorry for those who've seen this in the INT Area 1 on Monday. We are aiming for INT Area adoption. So if you think this is useful, please have a chat on that mailing list and discuss the things there. So my name is Richard Patterson. I work for a quad play operator over in the UK called Sky. We have around 6 million broadband subscribers on our fixed line network. Most of those, all of those are dual stack. Half of those are still using PPPoE. The other half haven't been moved across to IPoE, or more simply just DHCP. This draft attempts to add additional functionality in there to help sort out some of this operational issues that we still experience with IPoE. The catalyst for writing this draft was having yet another discussion with a peer in the industry around the benefits of IPoE versus PPPoE. So I went through all the obvious ones. There's less encapsulation. It's simpler for connection to establish. Most fixed line providers these days prefer to use port-based authentication, which makes chat username and passwords superfluous. And then after all of that connection establishment, you still need to run DHCP v6 over the top of that. The one detriment to IPoE that I couldn't really argue against is it lacks a session state tracking mechanism. PPPoE clients get this from PPP keep alives, where both sides of the PPP session send LCP echo requests to the remote peer and expect a reply in response. Now, if something was to happen to that path in the middle, the LCP echo replies will not get back, and both sides of the connection have visibility over this so they can act accordingly. The BNG can tear down the subscriber session, and the CPE can restart its PPPoE client, which would trigger the PPPoE four-way handshake and allow the BNG to authenticate the subscriber and get it back online. As mentioned, IPOE clients don't really have this functionality built in. So what some BNG vendors have done is they've implemented their own method of connection tracking using ARP and neighbor discovery checks. Now, if a customer was to unplug their CPE, the BNG would realize this, tear down the session, clear out the DHCP lease, and allow a new CPE to be reconnected. So in a broadband network with a layer 2 metro access network, if the BNG was to fail or go under planned maintenance, or if that metro access network was to be, the backhaul was to be rehomed to a different BNG, or there's another network element in the path that is behaving as a stateful DHCP proxy or a relay that could lose its state, then the CPE could be left with a stale DHCP lease for up to the valid lifetime. It still thinks it has a prefix delegation or an IPv4 address, so it'll be still sending packets to the internet via the BNG, but the BNG will just drop it on the ground because it has no idea who that subscriber is. Now, in this example, the lifetime was set to 1 hour. So what would generally happen is at half of that lifetime, so 30 minutes, the CPE will send a DHCP renew to the previous DHCP server, the BNG, to try and renew that lease. The BNG has no idea of this lease anymore, so it drops that renew on the ground. The CPE will keep trying, send this release, send the renew, and the BNG will keep dropping it until such time as that valid lifetime completely expires, and then the IPOE, the DHCP client, will restart the discovery and the solicit phase. The BNG can then re-authenticate and the subscriber comes online. So what this draft is attempting to do is to expedite that process and get that subscriber back online as fast as possible without adding any new messaging or any other crazy protocols. So reusing the existing methods and techniques we already have built in, mostly. The draft itself can be broken down into 3 sections: the parameters and the configuration thereof, the health check mechanisms themselves, and then the actions to take once a health check fails. Starting off with the parameters, we have the quite obvious interval, which is how frequently we will send a health check mechanism. The retry interval, which would be how frequently we would send it after an initial one fails. And then the limit for how many can actually fail consecutively before we consider the overall health check as failed, or the session down. The behavior is then which action should we take. The passive flag forces to passively check instead of proactively sending health probes. And layer 2 would force ARP checks or an ND instead of using an IP packet. The alternative target address is the IP destination or replacement instead of using the default. Pretty obvious there. Now, all of these parameters should be signaled via DHCP within the lease itself. So we specify new options for DHCP v4 and DHCP v6. And they're within the lease, so a CPE or an IPOE client may have multiple leases with multiple health check parameters ongoing at once. Or you could locally configure these on the CPE itself. There could be a default configuration, a user could override them via the user interface, or you can push it down via TR69 or netconf. The draft specifies 3 different types of health checks. Now, the first one is the preferred one. We've called it BFD Echo, but after a chat with Jeff Haas this week, we'll probably have to rename this a little bit because probably won't be full BFD. So a BFD Echo packet style will be lightweight. It's IP based, so it will use the forwarding plane of the BNG, so it shouldn't impact the control plane. And this is something that the ARP neighbor discovery or even just DHCP renews themselves will impact on the BNG otherwise. And it's also IP based, so it has the benefit of checking that the lease is actually still valid on the BNG itself, as the BNG would not forward the IP packet back to you if it had no lease. If for whatever reason the IPOE client cannot use this BFD Echo style probe, then it can fall back to ARP or neighbor discovery. This ARP or neighbor discovery will be for the default gateway, which would be residing on the BNG. And this could also be forced in with that L2 flag before. And likewise, if this IPOE client still cannot use ARP or neighbor discovery for whatever reason, or it is forced to use the passive flag, then it can fall back to just passively monitoring the ARP or ND cache tables on the device itself. Probably quite a lot there, so as Lorenzo mentioned on Monday, perhaps maybe we can fine-tune this and remove some of the additional options that we think were nice to have, but make it a bit overly complex. The actions to take then, we define 4 in this current document. So the first one, which is the default, is the renew. It would be considered probably the softest approach of the 4. It still has the same issues as we mentioned earlier on in the slide pack, that these renews may not be sufficient in order to bring this CPE back online, as a lot of things require solicits or discovers. However, this approach is in line with the current Broadband Forum's TR 146. The next option would be rebind, and this would skip the renew phase. It would then multicast or broadcast these rebind messages to any available BNG or DHCP server within that layer 2 access. Again, it still has the same issues as before, where you may not be able to re-authenticate the subscriber, but it could help in topologies where there are multiple servers. The third option is solicit, and this is the one that I see probably that we'll be using on our network, because this one skips the previous 2 phases, moves straight to the solicit and discovery phase, allowing that BNG to re-authenticate the subscriber and bring them online. It doesn't explicitly expire the lease, so the lifetime for the lease will still be present, which means the CPE won't withdraw any locally bound routes on the LAN or anything. So it should hopefully facilitate a renew of the lease without actually having to renumber as well, ideally. The fourth and final approach would be what I call the scorched earth approach. That's explicitly expiring the lifetime of the lease, completely withdrawing the lease from the local device, and sending a DHCP release through the network to clear out any potentially stale state within the network that could be preventing that client from coming back online. And that's it. Okay, Stuart.
My name's Stuart Cheshire from Apple. I have a couple of questions and observations about this. The whole context of it strikes me as kind of odd, because we've been running IP over Ethernet for like 30 years or more, and looking back at the history of ISPs, right, there was IP over Ethernet, which is connectionless, and then there were modems that you had to dial up and you had to make a session, and if it failed, you had to hang up and you had to redial. And 30 years ago was the whole battle between connection-oriented networking, ATM and virtual circuits, and connectionless. And Ethernet is connectionless, and if you don't have a connection, you can't disconnect. That's one of the great benefits and why packet switching won. So all this mechanism to manage connections over an inherently connection-less technology seems very odd to me. You talked about cases where your devices using ARP or neighbor discovery to tell if the client is still responding and reclaiming its DHCP lease. That is an explicit violation of the DHCP protocol. There are no liveness requirements. So if you reclaim a lease that you've given to a client, then and give that address to a different client, there's a reason the DHCP spec disallows that, and this is the reason.
So I'll pause you right there. I didn't say it reclaims the lease. It'll clear out the lease, and it could still keep a binding, well, a note within its local table for this client that's no longer there had this lease. And so it could reserve it for when that client comes back online, and that's what most of them seem to do.
So I think the real question is, it seems like an awful lot of work was done to create this problem so that we could do more work to fix it. If you just don't do that, if you just don't care whether the client's there, if you don't expire or retire, whatever terminology you want, if you give it a 2-hour lease, just let it be a 2-hour lease. Do not kill it prematurely, and then you don't have this problem in the first place.
So, yep, there's a couple of things there though. So there's DHCP leases, and then there's subscriber session state. Now, these are two distinct things that are kind of intrinsically linked in some ways, and in some ways they're not. So,
I guess I'm not understanding why you need this session state for a connection-less, session-less network technology. Why you need to put a session state on top of that when the whole point of packet switching is to avoid that failure mode?
Because this is a fixed line broadband network where we need to authenticate a subscriber for data retention and compliance reasons. We need to keep track of their radius accounting records to make sure that we know that that subscriber had this IP address or prefix at this given time. So when the LEAs come to us.
So I guess I have two other points. One is the way the IETF works is rough consensus and running code. If this is for clients of IP over Ethernet, that sounds like Linux, Mac, Windows. Which vendors have signed up to implement this? Because with no vendor support, you can write an RFC, it doesn't really matter.
Sure.
And then the final comment is, if you want some kind of liveness check, if that's what you really want, is to be hitting the client saying, are you there? Are you there? Are you still there? I don't believe you. Are you still there? Just set the DHCP lifetime to 5 minutes, and the client will send you this keep alive every 5 minutes to prove that it's still there.
So that second bullet point there on the BFD, echo 1, DHCP renews, we'll hit the control plane. And if I've got 100,000 subscribers on a single BNG, and I set 5-minute renew time, that's a lot of renews and hitting that control plane.
I think that's an implementation decision. If that's a problem, then don't put DHCP renews on the control plane, right? Implement those more efficiently. You don't need a different protocol, you just need a more efficient implementation if that's what you want.
Is anyone here from a vendor, Cisco, Nokia, and they can implement DHCP servers on ASICs? Come back and let me know.
I didn't say implement a server. I said if you want some keep alive packet, it's pretty trivial to just define the renew as
So
keep alive
they
packet.
don't even do ARP or neighbor discovery on hardware. That all gets punted up to CPMs or control plane.
I guess what it boils down to is if you want somebody to do some work to make this easier for you, the question is who is it going to be that's going to do that work?
We are. So we have our own in-house CP development team. We will be building this. France Telecom also have this issue. They've implemented something similar before this, so we've had a lot of feedback from Med to try and ratify this. Vocus in New Zealand, they don't have their own CP. In Australia, they don't have their own CP development team. They have this issue on their network. They can't convince vendors to implement something like this because there's no document to reference. So, yeah. So we plan on implementing this ourselves, and if we can get open source community to update their DHCP clients, great.
So which client devices do you imagine this running on? Because I was talking about Mac, Linux, Windows, and you're talking about CPEs.
I'm talking about CPEs. It's a fixed line broadband problem.
Okay, so this is not Ethernet within the home.
No.
This is the Ethernet cable between the CPE and the Sky.
Correct. Yeah.
Okay, and that is Ethernet. That's not DSL. That's not coax. That's actually Ethernet.
It's VDSL, which is Ethernet framed. It's GPON, also has Ethernet.
It presents an Ethernet interface.
Yep.
Okay.
So, Barbara Stark, AT&T, this has been a problem since we started doing IP over Ethernet 20 years ago. This is not a new problem, and it has been a problem, and the BFD echo that he pointed out is what everybody pretty much decided to do, and it is implemented in most every residential gateway and BNG that's out there.
I'm not sure about most.
Huh?
I'm not sure about the word most, but yeah.
So I guess my question is, does the BFD echo in fact meet your need? And if it meets your need, I mean, the broadband forum is, as you noted in TR 146 and in other places and in the residential gateway requirements, actually has the BFD echo sections. What do you really need for IETF to document that's not already there in a place that's much friendlier to service providers, I'll say?
Thank you. Great question. So yes, BFD echo as the echo, the asynchronous ones themselves would probably suit the purpose. The requirement that Jeff has mentioned is that you can't just say BFD echo alone. It relies on a full BFD echo BFD implementation on both sides. That may not necessarily be as lightweight as just a simple IP UDP loopback datagram. What was the other part of the question? Sorry. There was, oh yeah, so what else does this do? So the signaling of the actual parameters themselves via a DHCP lease, so that we don't have to have something manually configured or run on default, so that signaling between the network and the CPE, I think, will also be quite useful. And probably the main one is the behavior types. So whilst TR 146 specifies the health check mechanism, what prefers to use BFD echo style, it only has that top behavior, renew. So it doesn't actually help us get that subscriber back online quickly because we need to discover or solicit to authenticate. So I think having the alternate behaviors also is a benefit of this draft.
Lorenzo Calidi, I think you should just write down that that's a bug and needs to be fixed. Right, then basically you've got everything. You've got TR 146, which is presumably a bunch of people already have implementations of. If you don't, then you can add an implementation of it, right? So, and yeah, like I said in Interior, I mean, I think you just have too many options here, and the more options you have, the lower quality of the, at par of like implementation resources, the lower quality of the implementation, and the wider variety of bugs that you have to deal with. I don't think it's good for you. I did want to circle back to Stuart's point. You're saying that 5-minute renews don't scale, but it's not clear to me why. In the sense that if you're using DHCP, that's just sent up as a relay, right? Or if the BNG is a DHCP server, then I think if you're saying 5-minute things won't scale, but then you're saying that we're going to use NUD. NUD's expensive if it's done on the CPU. So yep. So an option would be to pull the DHCP server functionality off this network appliance and relay it to something maybe more centralized. But then again, you've got a centralized problem to horizontally scale. So you can't really get around that processing of that DHCP message. I mean, there are providers that I've heard of that. So I think Vocus also mentioned that they use a DHCP lease time of like 5 minutes or 10 minutes, so that it mitigates this problem somewhat because they're not doing any state checking, but it'll still come up within 5 minutes, and that's better than say half an hour or an hour. We couldn't really scale much quicker than an hour on some of our platforms without it actually impacting the CPU and control plane. I agree that that's probably considered a bit of a bug as far as RFC is concerned, as you pointed out and Jen pointed out. I'll probably have a chat to our BNG vendors to see if we could perhaps fix this. Authenticating on the renew would bring its own set of problems, because then the BNG doesn't know whether should I be renewing this when another BNG may have actually has that lease. So yes, the information will be in the renew packet, like option 82 or DHCP V6 option 37 remote ID. we could authenticate. It's just whether we manage that state in the between the BNGs, I think. So yeah, I think you're right. I think that's probably a bit of a conflict with RFCs.
I don't know. I mean, don't know about your network design, but it seems unwise to say that if a renew that the BNG doesn't know what the other BNG has handed out, and that seems like a risky architecture to deploy.
State syncing between BNGs is a complicated problem that I don't think any of the vendors have properly solved yet. It's a bit of a nightmare.
Like what's your strategy otherwise? You send a solicit and then one of them picks it up and the other one doesn't know about it?
Yeah, you have to manage your layer 2 domain a bit smarter. So this could be a simple it could be an EVPN, it could be point-to-point pseudowires, it could be with, you're handling with fast reroute and the pseudowires coming in different interfaces. You've then got even further problems where...
But how's the solicit special? How's that different than the renew?
Well, it's kind of assuming that it doesn't have a lease. So I guess the point with the renew is that the CP already has a lease to try and renew.
The renew is unicast, isn't it?
Sorry?
The renew is sent to the DHP server that issued the prefix, right?
So the V4 one would be unicast and V6 would be obviously multicast, but with a server ID. Yep, that's fine. So renew, yes, and then rebind would be broadcast or multicast to any available server.
And if you rebound, it means that basically all the renews failed.
Sorry, what was it?
If you rebind, it means that all the renews failed and they timed out.
Yeah, so that would mean that the that T1 is, where are we? Yeah, so the T1 value and T2 has both failed.
So basically you're saying if the network comes back after the renew has timed out, then you have a problem because you'll do rebind and then it'll go to both of them and one of them has it and the other one doesn't.
If you're in a multi-home sort of, or multi-BNG layer 2 topology, sure. I guess this isn't an issue if it's just a temporarily path failure and then the BNG still keeps the state. If the path comes back up, then it's not a problem. You won't, unlike PPP, the CPU won't even know there was a problem. It just dropped some packets and then carried on forwarding. I think your points on this, I think, are perfectly valid, but I don't think it solves the problem that it would still require the DHP lease to be quite short. So this is still generally half of the lease time. So it would have to be, if we fix this problem and I still had 1 hour leases, CPE could still be down for up to half an hour.
Sounds like you're trusting the client to do the right thing, though. I wouldn't design it like that if I were you. Even if you write the CPE software, those things, the things on the right are basically, if the thing on the left is able to corrupt the state of the thing on the right, then that thing is serving hundreds of thousands of users, and you don't want that to be unhappy. That'd be my advice, but.
Yeah, so
I'm not going to try to design your network here for you. I'm just going to observe that I think you have too many options, and I think you should sit down with Barbara and converge to fewer options. So
it's quite funny because that last statement is kind of in contradiction to the previous one, because I mean that's why this behavior exists, to protect itself and the network. So the RFC may say you should be able to reply to that renew, but the BNG is protecting the network from an unknown subscriber. So if you're saying we should allow these to come in from an unknown subscriber.
It's a renew. You have the state.
It doesn't have the state, though. Sorry.
Barbara Stark, he's taking the right approach.
Thank you.
No, he said he didn't want all the options. He wanted to figure out which was the best option, but he's right that it's something that needs to be done at the client because the client is the one that knows that things are not working. That's the place where it needs to be done, and it has never been perfectly solved, which is why 20 years later, it's still a problem, and every now and then I still get emails as to, what are we doing on this again? Anyway. And yeah, the BFD Echo was the best that people came up with.
So I think the point is that neither this bidirectional checking hasn't existed. Some BNGs have implemented a unidirectional check, which actually exacerbates the problem from a CP point of view, because now the BNG will clear the state even quicker than, say, 1 hour of lease time. So BNGs trying to do the right thing in that direction have made it worse in the upstream direction. So all I'm trying to do is get from that unidirectional state to that bidirectional state. So I'm just trying to implement what PPP has done from both sides. Thank you for comments and discussions.
Okay, thank you. Eric?
Try to remove the mic, that's not working. Anyway, so for the people that were in Terraria, the slides will be different because I will start from scratch. So you will get explanation about what the PVD is and what is the problem statement that you are trying to solve. So my name is Eric Vink. I am one of the 5 authors, and many of them are here. Pierre is here, Tommy is here, David is maybe in the building somewhere, and Wenchin is back in Paris. So, when the internet started, and we see in the previous slide, it looks like we have a single connection, but it's no more the case. If you think right now on your laptop, you most probably have Wi-Fi, at home you have wired as well, and you may even have using Bluetooth to tether with a mobile phone. So you have at least, like on this slide, 3 interfaces. Now, on some interfaces, such as the Wi-Fi, you have maybe 2 upstream routers if you are rich. Think about a small and medium business. And in some cases, you have even a VPN coming from a box to corporate. And a VPN is basically another connection to the internet, or at least to some IP address of the world. So basically here, you can go out through the mobile service provider, ISP1, ISP2, and VPN, and you get 3 physical interfaces. Honestly, I have only 1 ISP at home, but all the rest I have. So I have this problem sometimes 2 times at home. So now, fair enough, you are connected, but how do you route this? For instance, assuming you select the wide interface, which interface you go out? ISP1, ISP2, routing will tell you which address you use. In the case of IPv4, the legacy protocol, right? We have only 1 IP address. So if you exit to ISP1 using an address from ISP2 and is doing anti-spoofing, as it should do, it will be blocked. So combining minus times minus making plus, the only way to make this working is to use the N word, NAT. You do NAT if you exit to ISP1 by using an ISP1 global address, and then the traffic is coming back. Good, but we are in V6OPS, not in the legacy ops. So how do we do it there? That's one problem statement we want to do. Easy multi-homing. Again, large corporation do BGP peering, you use your own PI space, not a problem. Talking about PI here, right? About small SMB. Multiple draft, I tend to use this, that's what I say, PA or PI address, that's fine. Jen and others has got draft as well to select which router to exit. They are part of the solution, but what can we do more? Another issue was explained by one previous author, Marcus Keane, at that point of time was working for Microsoft IT. And he showed me this slide, he showed us this slide, the IETF 99, about a year ago, where basically on the left-hand side, this is Microsoft Corporate IT, where they got a different prefix in US compared to Europe. One ARIN and one RIPE prefix. There's a blue, greenish cloud on the left. But they want a local breakout. So meaning if they want the traffic to go to the internet, they need to use local address and not go to the corporate network. So that's the blue. And the blue is giving them a prefix like 2001 DB8. obviously the example. And as well, they want to go to Azure. But Azure in Europe is using part of the prefix of Microsoft RIPE prefix, right? I mean, it does make sense if you want to do an addressing plan. Now, people at this office, the PC at the bottom, basically receive two prefixes by using arrays. One from corporate, EMEA, and one from the local ISP. Now, look at this. We know that the source address selection will always prefer the longest prefix match if you don't cheat with it. So, I want to go to the Azure in the cloud. Which address I will select? Oh, I receive a 2A01 address from my layer 3 VPN, the greenish part. So if I go directly to Azure on the right, the ISP in blue will do BCP38, anti-spoofing will drop the packet, right? Bad. Now I want to go to, let's say, a bookkeeping website or to manage my vacation, which is on the green left cloud. So 2001. Which address do I select? The ISP address, which is 2001, the longest prefix match. So I go out maybe by the left part because I'm routed there to the right destination, but the reply will be sent to the ISP, right? So obviously it will not flag. Ted Lemon has got another issue at the same IETF in a different group. If you have two interfaces, for instance, on my phone here, I'm from Belgium. If I ask the address of a newspaper over the cellular link, it will exit in Brussels, and I will go to an Akamai website close to Brussels. And now, if I use for the data the wide from the IETF, I will travel back to Brussels, which is not optimized. But even worse now, if I make the DNS resolution over the wireless here, I will mostly get an Akamai website here in Montreal, while if I do the data transfer over cellular back to Brussels and costing roaming for me. Okay? So basically the point here is that we need to make a bundle of information. The interface, the address, the DS name, and the next stop. And this is the old RFC coming from the defunct MIF Multiple Interface Working Group, RFC 7556. They define provisioning domain. Provisioning domain is a consistent set of network information. As I said, interface, address, next stop, routes, because you can get specific routes, DNS servers, and so on and so on. So our draft has come for goal to allow to identify those PVD, because you can get multiple of them, at least one per interface. In IPv6, you can get multiple routers and multiple prefixes and multiple addresses. So in the case of V6, multiple PVD per interface, as well as giving you more information about the network itself. It's already good for connectivity to have a bundle, so you don't get those issues mentioned before, but you need to know how I can select this specific IPv6 address compared to the other one. Okay, how we do it? So we had the draft. It's a revision -02 right now. It's a working group item in Interia. Before it was a personal draft. Basically what we do, we add a PVD option into the route advertisement. We have a type already allocated by IANA, which is 21. Couple of bits, I shall come back on this. The main thing in the middle is the PVD ID fully qualified domain name. We use a fully qualified domain name for two reasons. One, we can be sure they can be unique. Like fully qualified domain name can be unique, even if they refer to multiple servers. As well as we will use it to access more information by forming a URI based on this fully qualified domain name. So two purposes here. Then after, we may repeat a route advertisement in this option. And I shall explain to you later why. Some flags. H, it means HTTPS. It means please do build a URI based on the fully qualified domain name is there to fetch more information. If it's not there, don't do it. If the flag is there, you may do it. L means for legacy, IPv4. We identify with this PVD all options into the array. But what if you're dual stack? What about the IPv4 information that I'm receiving by the HEPv4? If you put the bit L, it means that this PVD is associated as well with the IPv4 information. Obviously, you can only get one array with one PVD with L bit. It's up to the operator to do it correctly. And R means that typically there is a repeated routing advertisement below, explaining this later. Sequence number, what's this? It's simply to tell you, hey, I have changed the PVD somewhere. I have changed the information. How do I notice it's a different one? It's a new one. That's when we change the sequence number. Then it can trigger a refresh of all the information in all the hosts. Of course, if you have a large conference with 20,000 people, let's say, or 30,000 on the Wi-Fi, you do not want everyone refreshing the information at the same time, fetching the additional information of SSL, right? Because the SSL server will be a little bit overloaded. There's a reason why we put in the top right corner delay, which is an exponential delay. Look into the draft to see, but it's basically something between 1 second and 50 days, which is random. So you delay a random time between now and up to 50 days to refresh your information. Okay? And by the way, we are here to get operational feedback, so feel free to ask questions and put comment. This is for your leisure in the plane back from here, because you don't get the sound. That's basically what I just explained. Example. So look at this one. So full the value, so 21, no bits, so no additional information and no routing header repeated and nothing to do with IPv4. Sequence number, I could have put any number there. And then we express the fully qualified domain name in the way DNS requests are written. So it's not with dot in ASCII. It's really how we ask for a RR or A or whatever on the DNS. Some padding. And now we have inserted later two normal array options, one for the DNS server and one for PIO for some address. And if you look about the length is 12. Now look about this. If I am a PVD aware host, I know how to handle those options. Right now there is none except some experimental code on Linux. I know that it's a PVD. I know the length, I know the structure, so I know exactly where the sequence number is. I know the length of the DNS field, the fully qualified domain name, because there's a structure. I know there is some padding to align on the 8-byte boundary. And then I continue the parsing of the recursive DNS server and the PIO. And then, of course, I go to the next one. So basically, I look at all the options contained into the PVD. Okay? Now, if I am a non-PVD aware host, oh, that's an option. I have no clue how to parse it, but I skip it. So I use the length and go directly after. I don't look what's inside. Okay, so if we are sending now PVD in all our hosts here, you will ignore completely the PIO, so you don't use an address from this one, and you will not use the DNS server. So it means that we can deploy PVD to everywhere. It will break nothing. It will bring no added value though, okay, but it will break nothing. Now for the PVD aware host, now they can know, oh, if I'm a PVD aware host, I can use this DNS server and this PIO. Okay, so think about it. Very simple case. You use one array with a single option in it, the PVD, that includes PIO and DNS. So if I am a PVD aware host, I will use this address and this DNS server. If I am a normal host, I will ignore it because there is no address inside. Okay, and if I put on the outside header, I mean the normal routing header, routing advertisement header, lifetime 0 for the router, I will not use it as the default router anyway. But if I repeat inside the PVD options the route advertisement header, with a lifetime being greater than 0, I will use this as a default route. We have one use case with a big service provider in Europe that want to use this to advertise a specific PIO and specific route for the TV, for instance, the set-top box. Because then they will be PVD aware, they will accept the PVD fully qualified domain name, and basically use this PIO and this exit route. A very clean way of doing a walled garden. Okay? If you remember what's happening in Japan years ago, with the mix-up of the walled garden and an ISP, we avoid this. And multiple other use case. Now, remember I said there is an H bit. If there is the H bit is there, the node may, uppercase may, from this URI, get https / fully qualified domain name .well-known /pvd. And basically use HTTPS or TLS, right, to access it. What's there? Inside is a JSON file where we repeat the name that could be displayed in a better way than the fully qualified domain name. That's optional. There is an expire date, pretty much like expires on any HTTP content. So you should refresh it before this time. And again, we do some randomization there to avoid everyone fetching at the same time. The prefixes, which is there, this is the list of prefix, typically /48, /32, that are allowed to get this information. It basically, I have many more slides regarding the privacy and the security of it that I don't presenting here. We can do it offline if you want. It's to raise the level of security of this. It can still be spoofed, right? It relies on route advertisement that can be spoofed. So nothing really magic there, but we try to raise the bar. Now inside this additional information, beside those three information that are in the draft, we have at least another draft in Captive Portal that specifies this key, Captive API. And that's a draft from the two gentlemen there, Tommy and Pierre. In short, to summarize at Captive Portal, one issue is that the redirect that we all know in the hotel, in the station, in the train, and so on, does not always work because of TLS and HSTS. So they need to find something else. So getting the URI where you need to connect to enter username and password or credit card number and blah, blah, it's very important for them. Okay. And we can get we were talking with other people about providing information as well about the upstream connectivity. Right? You can sense very easily how fast your Wi-Fi link is, but you don't know the speed or the bandwidth between your access point and the access network. Could be an old 2 megabit per second line, could be a fast ethernet, could be a gigabit. So this may be important for your application. The goal of this JSON file, just to be clear, is not to change the layer tree. The layer tree is communicated by the route advertisement, period. Is to provide additional information to application. And we sincerely believe it could be very useful for many, many use cases. Because then network can, with some sense of security, but not full security again, communicate to the application what are the services, what are the characteristics, what are the properties. If you use this PIO, that could be routed differently, and this interface that could be routed differently. We can receive as well 2 PVDs with the same name from 2 interface. Why not? Okay, those could be considered sensible, exactly the same, for instance. So, as I said, we are making big progress on this. We've got in spring the number from IANA. So this is reclaimable in future. As long as you don't get an RSC, it's reclaimable in future, but its option is 21. Implementation status, if you go on GitHub, you will get many, many implementation. So sending this array with those bits and this structure is kind of easy. So we have modified array DVD, typically for Linux, and ODHCP, as well, which is also used in OpenWRT. And working for Cisco, we also have some experimental code in iOS there. But it's very simple, right? It's sending an array with additional bits. On the receiver side, we have another easy one, which is Wireshark. So we can decode all the options there, which kind of an easy one. Which is more complex is we are working for many months on an open source implementation of the Linux. It's not so much about getting the array and getting the options right. I mean, that's easy. It's more being able to make a bundle in the Linux code, independent of the array, of the PVD. So linking the route, the address, the DNS server, which is in the user space in Linux, right? It's in libc. So it's working now. So you can download the code. And basically, you are more than happy to help you there. For instance, in London, we had hackathon with all those people over there. A couple of those people are here, basically to testing the captive portal with the latest code there. And it was running fine. Okay. And basically, that's it. So I came here to present to you. So the intent of this draft, we are pretty good shape in Terraria. Our intent, we received some comments to change maybe the wording to be clear. For instance, what do we do when we tether a phone to the rest? Obviously, we should propagate the PVD option to the tethered phones to the different clients. The similar thing, nothing really dramatic. And we intend to go on last call after Bangkok. I still need to present this to 6man because we changed the IPv6 protocol, but it was on Monday. It was a little bit too short. Fred was kind enough to accept me here. So comments, review.
Specifically, you want those comments on 6man or on Terraria?
Whatever. We want to comment. It's better if you put Terraria and CC, of course. But I know the pain as well. When you don't follow a working group, you don't want to subscribe just for one thing. I am following V6OPS, obviously. I am following 6man. I am following Terraria. Post it wherever you want. Okay. That's basically it. Or go to the mic. Or we have basically 1 hour and a half. So be a bit early to go with around the beer, though.
Yeah. Yeah. Okay, so this is a completely shy group. People are scared of walking up to the mic. They just never do.
Yeah, they see my big teeth, right? And my clothes.
However, if anybody has comments now, please feel free.
Really feel free.
Hello, Tom Jones, University of Aberdeen. I see my name there. So we use the PVD information in the EU NEAT project, which is a project to build a next generation replacement for the socket API. And this sort of information that could be signaled from the network turned out to be really powerful to use, and it allowed us to build applications which could make decisions about the network at a high level, and the network could provide a reasonable level of guarantee. And I would say to any operators that this is a path forward for a more adaptable internet, and it's definitely something worth looking at.
Thank you. Eric?
Eric Nygren. One thing that might be worth looking at or kind of looping in with is the discussion that happened in DRIU yesterday, where they were because one of the things that's being discussed there is in particular on DNS server discovery. And there was a discussion on when do you trust the network? If you're going to be using DNS privacy or DNS over TLS, when can you trust the network or DHCP v6 to go and give you here's what DNS server to use? And I think a lot of the first pass summary coming out of that was you can't really trust the network enough to get name servers from it for some of the privacy use cases. By feeding in some of the PVD ID, there might be, and thinking through how can you bind trust of PVD ID to certain devices, so devices can say, I trust this PVD ID if I've authenticated it, but not others. There might be some path forward, so it might be worth kind of looping this discussion in with that one if you haven't.
Okay, thanks for the tips. Will do. Another Eric.
Another Eric with a K. Eric Klein. I can't recall from the end of the document. What does it say about defining new keywords in the JSON?
You mean
Is it standards action or is it
it's,
expert review?
we put this, if you want, currently in the IANA consideration, we say IANA please open a registry for those keys.
What about
So
review
we
for adding
expect
new ones?
basically to get IANA entries or new draft, but outside of this one. We want to keep this one very simple.
No, yeah, I understand that, but I think there needs to be a recommendation for how to add new ones, right?
We put it in the IANA consideration. We ask them to open the registry if I got you to right, but I'm not sure.
I think that's actually two different things. I think creating an IANA registry is one thing,
Mhm.
and the means by which you update it is a separate thing. Is this true? One possible thing is that every new option needs a new document, and the other option is everything needs well, it's in a new document, but it doesn't have to be, it needs expert review, the way DHC used to run, or runs.
Okay, maybe there's some process I'm not aware of, but we will.
Somebody who knows process better will know more than me. Warren, perhaps?
Oh, yeah. Thank you for this.
Jen Linkola, network operator. I really like it because from experience, for example, at IETF and V6 only network, the main issue I've seen was DNS split horizon between VPNs and V6 only network. If you're on V6 only network and you're on the VPN, even if it works, I mean, getting established, then you either start using your corporate DNS and everything breaks because it's not DNS 6.4. Yeah, so basically, yeah, we need to, and my multi-homing draft also mentions that it's actually probably the biggest unsolved problem because you can solve the routing issue using SADR, but as long as you start seeing DNS split horizon and you need actually to use the proper DNS and combine it with network information. Yeah, so this is a great work on solving this.
Okay, thank you. And maybe we can add this use case as well.
Good Lord, how tall do they think I am? So Warren Kamari, following up from Eric's thing, it's not only adding new things, it's also what should you do with ones you don't understand, right? Most of these I think would be optional, but possibly having some if you don't understand this, please don't use it. So breaking this search space up into two.
Okay, thank you. Thank you to both. Okay.
Okay, we're good.
Thank you for your time and your feedback.
Okay, if anybody hasn't signed the blue sheet, please grab that. Let me just kind of throw the floor open. Does anybody have something they'd like to kick around?
Yes. Brian Carpenter. Those of you who were in the RFC++ BOF on Monday evening might have heard Martin Thompson make a remark about the awfulness of STD25 standard, IETF standard number 25, well, actually Internet standard number 25, which is also RFC 867. I just wanted to give an implementation report on that standard for IPv6. It's 12 lines of Python. That's my version. Martin wrote one, which is 1 line of JavaScript. And my client, which is actually only 6 lines of Python, interoperates with his server. I don't know if he's got a client which would interoperate with my server. Anyway, they interoperate very nicely using IPv6, so I didn't even bother to implement an IPv4 version. So this is a standard from 1983, I think, which probably hasn't been used for the last 20 years, which was criticized for being badly written, which we both managed to implement for IPv6. During working group sessions, of course.
Okay. I should mention we had an outcome from the discussion yesterday of the Pref 64 Internet draft. Warren has taken the Cheshire draft on IPv4.ARPA to IPv4only.ARPA as an AD sponsored draft and basically saying, please make it so. And as we discussed yesterday, Lorenzo and Jen and Eric filed a draft saying, what if we use an RA option? And I understood the working group, the people here, to be saying, yes, let's do that. So this morning I sent a note to the 6-man chairs saying, dear 6-man, please make it so. And, I'm sure there will be updates to the draft and there will be discussion and so on and so forth. But the point is that's the direction that I understand the operational community to be suggesting that we go. Warren.
So, Warren Kamari, I think that a number of people think that the RA option is a good idea, or at least that's sort of the feeling I got. And I think that a number of people don't much like RFC 7050 and the whole DNS with the magic and the stuff. I must admit, I'm not a huge fan of 7050. I think that many people view it with a somewhat jaundiced eye, but I think that what the document that I'm sort of AD sponsoring doesn't say that 7050 is brilliant or bad or anything. All it tries to do is make it, this is already deployed. Let's try and take some of the sharp pointy edges off it so that people who are using it don't shoot themselves in the foot. So I think that, regardless of what happens with an RA option, making 7050 less dangerous or less tricky to implement is still worth doing. So if anybody thinks that the document that I'm AD sponsoring is really dangerous, I'd love to know that. But unless I hear that, I think, making it suck less would be good.
Yes,
Oh dear, hang on a second.
Stuart Churchill.
I saw Lorenzo pop up and I'm like, maybe I should vamp now to the, okay.
With one more person at the mic, we could have the entire authorship of the Pref 64 draft standing at the mic.
I just wanted to say, thanks, Warren. That's a good summary. I'm not especially a fan of 7050 either. When we were implementing it at Apple, we ran into problems where when users have overridden DNS or they're using VPN, with the discussion this time about DNS over TLS and over HTTP, I think it's becoming more into the spotlight. I think a couple of years ago when we identified this problem, a lot of people hadn't seen it. I think more people are seeing this problem. So the reason that David and I wrote that draft and we literally bashed it out in about 1 hour with a couple of beers in our hands at Apple.
Yeah, I noticed. Sorry, snark.
So if we are going to use 7050, our draft points out some of the problems and what you have to do to make it work. I'm not especially advocating that, and I'd be fully supportive of RA or other suggestions that people have. But if we are we should either deprecate 7050 and say don't do it, or we should say how you should do it so that it works.
So thank you. I was actually going to follow up from that. You made my point kind of for me. I've heard some people say, the 7050 thing does not work hugely well. How about we just deprecate it? I've heard there's some people have. I don't think we can do that. It's widely deployed. If somebody does want to do that, that should probably happen in a different document or somewhere else, not here. Separate discussion.
Okay, Jelenkova. So first of all, we've just uploaded 0.1 because 0.0 version was a bit incomplete. So it addressed some of the comments received yesterday. So we basically clarified all those load balancing, routing, like give some examples of how it should be done and what is in scope, what is out of scope to avoid confusions. So everyone who commented yesterday, we appreciate if you can have a look and let us know if new text is better. And I will send update on 6-man mailing list, so I think we should actually have discussion in one place, because sorry, I did yesterday, we uploaded the draft, but we did not send notification on the list. And I wanted, 7050. So I reread 7050, and it looks like actually there are two parts there. Is how you get the prefix, and the very interesting part of what host is expected to do when it gets the prefix. And currently, our draft is saying when host gets the prefix, the behavior should be similar to what 7050 does. Especially it applies in situation when you have more than one prefix. What host supposed to do and so on. So if people talking about deprecating 7050 or saying it's dangerous, we need to probably make it clear if we're talking about discovering the prefix or host behaviors in terms of what is expected from the host.
Yeah.
Yeah, I don't know if Lorenzo. Yeah. So coming back to discussion about the error option and so on, I think that's the draft you just submitted two days earlier, there are some discussion which is ongoing. I think that it's too early to have that in this kind of profile document which is currently edited by Jordi. I think that the discussion can be separated from the current profile, so that the profile can continue in its own route, and have the era discussion in 6 months, whether the people change their minds since the consensus that we have in Behave Working Group when we produce the RFC 7051. I think that the other option, it may seem, I would say, intuitive and so on, but it has a lot of issues there that need to be solved and discussed. And the other point is that if you see, for instance, the text proposal from Jordi there is this text about your putting to the other option, and there is this new text which is prioritizing the way, in case you are discovering the prefix in multiple ways there. So you start with 7225, which is for me superior to the other because it is really deterministic and it solves the problems there. And then you go to the DHCP option, and then the third option with DRA, and then you end up with 7050. So we have already multiple options and ways to discover the prefix. So what's the point to add another EA solution to do something which does not solve the problem that we have with the, for instance, with the 7050 and also with the DHCP option. So I think we have too many options there. It's what the point to add in another one and so on, this kind of discussion, and to separate it from the profile, so that I don't think that it's, for me in general, I don't like to have individual drafts in stable profile documents because it does not make sense at all there. So that's my suggestion to the working group, is to remove this discussion from the Jordi's drafts.
Lorenzo Colletti, as an author of 7050, as an author of the drafts, as an implementer of 7050, I agree with Warren. 7050 is hard to implement. It's particularly with its interactions with DNS over TLS and VPN, it's the wrong way to do it. That said, Mohammed by himself is in a position to block our new draft until the IETF closes. And so there is no guarantee that this draft will ever survive 6 months. Therefore, from a pragmatic perspective, sure, fix 7050. If we ever get something better, we'll deprecate it, but that could take 8 years, 16 years, like whenever until we retire. It could never happen because that's how 6 months works. So yeah, don't hold your breath for us. We're trying to do the right thing. We're trying to also say, look, we have a bunch of stuff that we standardized earlier. I looked at 7051, and reasons not to do RA were tenuous or basically invalid at best. But of course, if we say, well, we already have too many ways of doing this, even though only one of them is implemented, then it's like, yeah, I mean, if that position stands, then we go nowhere. And so, yeah, fix 7050 by all means. And then, people will be unhappy with it, but until we get a replacement, I can tell you for one thing, it's not going to be 7225, because I'm never going to implement that because it's way too complicated. So we could just, so yeah, let's fix 7050. Yeah. But that's how we can pragmatically proceed.
Yeah, I think that's the point with 7225 is not only to solve some of the issues there, but also it solves the problem. If you have a NAT64 and if you want to cover the incoming connection, you need to solve this problem too. And then why it's something that you say that you are solving not only the discovery of the prefix there, but you are solving other issues that you are encountering within NAT64. So it's one tool that will solve you multiple issues. So, but that's for me, we have the PCP server, which is implemented in NAT64 devices today. We have multiple vendors who are offering already that. We have an issue with the handset to have the PCP client to be supported, at least for the mobile handsets there. So if you think it's complex to support PCP client at the handset, yeah, what should I say more? So yeah.
Yeah, I just meant that if there's a disagreement on this new document, and it looks like there is, then that may disagreement might never resolve. And so, yeah, that's all.
Three, two, one. Okay, we're adjourned. So thank you for coming this morning. Is this working? I'm expecting a rush toward the door.
Yes, it's